longitudinal designs, or one particular kind of longitudinal design, to be honest. So here's my favorite example. I'm going to have to actually just run this study just so I can talk about it. But, so we want to study, instead of looking at like people writing about a time of scarcity, we want to look at how their actual experiences of scarcity in real life affects their prejudice. But we don't want to manipulate their experience of scarcity in real life because that's super unethical, right? We can't just, I guess we could rob them or like transfer all the money out of their bank account, but that seems wrong to me. Maybe we could do that like in social psychology of the 1970s, but not. We could use a cross-sectional design, but then we don't know if scarcity affects prejudice, or maybe prejudice affects scarcity. So maybe if you're really prejudiced towards people, you can't like have a hard time keeping a job, and so then you don't have as much resources because of that. So instead, what people often do, myself included, is we use longitudinal designs. I think this is actually really a useful approach. I like longitudinal designs for studying social psychology stuff because I'm skeptical we can manipulate as much as we want to manipulate. And so this is a useful tool. And the typical way that we do this is we do something called a cross-lag panel model, which would look something like that. We measure x, whatever that might be, at time t, and we predict how it changes stuff in y at t time t plus 1 or time 2. So we're looking at this red path. And so if we do this across like panel model design with this real life example, we measure both these constructs at 2 time points. We estimate a cross-lag panel model. And basically what we do is we estimate this model is we have scarcity measured at 2 time points. We have prejudice measured at 2 time points. The path model includes these paths, time 1 predicting time 2, which are stability coefficients. Just how stable over time are they. And then cross-lag components. The red one is the one that our hypothesis that I made up for this example is about, but it also looks at the reverse effect too, which is potentially interesting because some psychological processes might have feedback loops, and this taps into that idea. And so basically the idea then is that cross-lag effect, the red arrow there, significant? And if so, it suggests that scarcity affects prejudice. That's the typical way people think about those designs. And unfortunately, it's wrong. Which sucks, actually. Because this is, I'll explain why it's wrong, don't worry. But and it's really unfortunate, but this is people in the longitudinal modeling world have basically figured this out probably 9 years ago now, but it's only like started to filter into for the rest of us the last few years. So the key problem with this model here is that it assumes that all of the variables are primarily affected by their prior selves and some other prior causes. So scarcity here, scarcity exists in this model only as a function of itself at time 1 and prejudice at time 1. Now, that doesn't seem like maybe a bad thing necessarily, but what if scarcity is not caused by time 1 scarcity, but rather it's more of like a trait, not a personality trait, isn't quite the right word here, but there's some people who just chronically have more scarcity than other people. If that's the case, that is totally absent from this model. And so anytime there is this possibility of having a trait component, or a stable thing that's across time, these models don't capture it at all. So that means like if you have personality in here, which we know has a trait component, that's its whole point. These models don't work. If you have something like height and weight, it's not, your height is not affected by your prior. I'm not taller today because I was taller yesterday, right? I'm taller today because I have some combination of genes and nutrition that resulted in this. Same for weight and hair color. Like my hair color today is not this color because it was this color yesterday, right? There's another stable trait that causes that. Same for prejudice. This suggests that the prejudice towards these outgroups in my hypothetical study are only caused by the prejudices as outgroups at the prior time point. But if there's any degree of stability in that over multiple time points, like there's some people who are just more prejudiced towards others than other people, which you might know some of these people, then this model misses that. So by ignoring the stable variance, it means that this model is misspecified. Now, misspecified just means that the model as it's written here doesn't capture like the data generating process that's happening in the real world. Most statistical models don't capture the data generating process in the real world, and they still work fine. But people have done simulation studies, and when this is misspecified, and especially if there's a stable component, it's almost always wrong. Almost always. So they're really dangerous to use because of that. So this is the kind of part of the reason that this happens is that this model here, the standard cross-like panel model, and this model here, where prejudice is and scarcity are these stable traits causing people's responses, and they are correlated. The traits are correlated with each other. This model and this model, when you fit them in a path model framework, are mathematically identical, and you can't distinguish them because with just the 4 points of data, you can't add any more paths to these models. So you could estimate this one, and you learn how these things are correlated, but you get nothing about the cross-lag effects. Or you can estimate this one, and you get nothing about the traits. But both of them are probably wrong, because this one is assuming there's no cross-lag effects, there's no other of the stability stuff, and this one is assuming there's no traits. And so when you have two waves of data, you cannot distinguish between these two possibilities.